Hi everyone. This is the second half of example 5 from chapter 12 in the student packet. So just to remind you, we're using the same distribution of M&Ms. And as a reminder, I've got the probabilities over here on the right. So the probability that we choose a brown and a red each are 0.1, and the probability that we choose a yellow, blue, orange, and green each are 0.2. So the problem says if you pick 4 M&Ms in a row, what's the probability that they are all blue? So what we are finding here is the probability that we choose a blue, and then another blue, and then another blue, and then another blue. So this is a multiplication rule. Because choosing colors of these candies is generally independent, we can multiply each of these together. So this will be the probability that we choose a blue times the probability that we choose a blue times the probability that we choose blue times the probability that we choose a blue. And this is going to be then 0.2 times 0.2 times 0.2 times 0.2. And you can write this as 0.2 to the 4th power, or just type that into your calculator and you will get 0.0016. Notice I did not round too much. Whenever I'm doing a multiplication rule, I try to make sure I'm keeping 3 or 4 decimal places. All right, for part E, it says, what's the probability that none of these 4 candies are green? So let's just start by figuring out the probability that one candy is not green. So I'm going to use the notation for complement. So not green is the complement of choosing a green color. And this is going to be 1 minus the probability of choosing a green color. Well, choosing green is 0.2, so 1 minus 0.2 is 0.8. So choosing a green M&M, the probability is 0.2. Choosing any other color other than green, the probability is 0.8. But now I want to look at the fact that I have 4 M&Ms in a row. So this is going to be the probability of not green times not green times not green times not green, or 0.8 times 0.8 times 0.8 times 0.8. And again, you can write this as 0.8 to the 4th, which is 0.4096. In part F, it says, what's the probability that we choose at least one red? And this is a different type of complement problem. So we have 4 M&Ms. And within choosing these 4 M&Ms with the color red, we have 5 scenarios. We could choose no red ones out of these 4. We could choose exactly 1, exactly 2, exactly 3, or exactly 4. Those are our 5 scenarios that we have. When we say what's the probability of choosing at least 1, that means that we're choosing 1 or 2 or 3 or 4 red M&Ms, which means that the complement of choosing 1 or 2 or 3 or 4 is the leftover scenario, which is that we don't choose any. So the probability that we choose at least one red is going to be 1 minus the probability that we choose no red. Well, that means that we don't choose a red, and then again we don't choose a red, and again we don't choose a red, and then finally we don't choose a red again. Well, finding the complement of red, so I'm just going to do that over here. So the probability that we don't choose a red is 1 minus the probability that we do choose red, which is 1 minus 0.1, or 0.9. So over here, that means we have 1 minus 0.9 times 0.9 times 0.9 times 0.9. Be sure to follow your order of operations and do your multiplication first. So you're going to do 0.9 times 0.9 times 0.9 times 0.9, which is 0.9 to the fourth, and then take 1 minus that, and you will get 0.3439. For the last problem, it says that the fourth one, the fourth M&M, is the first one that is brown. So that means that we are finding the probability that we don't choose a brown one, and then we don't choose a brown one, and then we don't choose a brown one, and then we do choose a brown one. So again, I'm going to figure out the probability that we don't choose a brown over here on the right. So the probability that we don't choose a brown is going to be 1 minus the probability that we do. And brown is 0.1, so like the red, this is 1 minus 0.1, which is 0.9. So for part G, we have the probability that we don't choose a brown, that's 0.9. And then the probability that we don't choose a brown again, and then the probability that we don't choose a brown again. But the last one is that we do choose a brown M&M. And if we take 0.9 times 0.9 times 0.9 times 0.1, we will get 0.0729.